scenarios. Remember, they are not the only scenarios that we have. They are just snippets of what can possibly happen. All right. So we are busy looking at the formulas that we can use for each one of them. For the blue forces, is the object moving up or down like that? No. So because it's not moving up or down, because in the vertical it is stationary, we are looking at Newton's first law. Poki, please give me Newton's first law in words. An object will Beautiful. Right, so when you look at it, I chose up to be positive. Then it's the up minus the down. And we have a formula to calculate FG perpendicular is FG cos theta. If you chose down to be positive, then it will just be FG perpendicular minus Fn. But you should get the same answer at the end. Alright, then if we look at the yellow forces, so they are the horizontal or the parallel forces. Kuma, which direction did you choose to be positive? To the left. Why did you choose to the left to be positive? There's two forces going to the left. Alright, yes. So she has FA plus FG parallel minus FK is equal to 0. Sorry, I wanted to say why 0? Is the object stationary? No, the object is not stationary. It's moving at a constant velocity. Constant velocity is also Newton's first law. So even though it is sliding down at a constant velocity, we're thinking, it's still F net is equal to 0. Mosi, why are you frowning? Did you choose to the right to be positive? Yes. Then you will have Fk minus Fa minus Fg parallel. Chop. Okay, right. So here there's a couple of ways with what you could have done on after this. Okay. Fa we can't determine, we can't elaborate it, we can't make it into smaller things. But Fg parallel we can, it's Fg sin of theta. And Fk we can, it's Uk times Fn. Okay, then you can take some of it to the right hand side, left hand side. I'm not going to do all of that now. Mosi, what does the UK stand for? Starts with a K. Well, it sounds like a K. Friction. Coefficient of friction. Mama, does the coefficient of friction have any unit? Is it newtons or grams or seconds or... The coefficient of friction has no unit. No unit whatsoever. It's only a ratio. It's only a ratio. No unit. And that coefficient of friction is dependent on one thing. It's dependent on the type of material that you have. Type of material. It's all written on your first page at the bottom. We highlighted it, I discussed it. I use your flip file and I use a tile and whatever to explain it. Alright, then the last type of motion that we have is acceleration. Tiamo, when you hear acceleration, what do you think of? And go for it. Yo, on fire. All right. Okay, well done. One word that you missed, but it's not the end. You said acceleration is directly proportional to the net force. But it's fine. It was good. Right. So if we look at the first one, when it's on a horizontal plane, our free body diagram, We have our applied force to the right. We have our, that will be again Fk. It will be kinetic frictional force underneath. Why kinetic frictional force? What's the difference between kinetic frictional force and static frictional force? Here we had Fs, static. Here we have Fk. Here we had Fk. When it is stationary, when it's not moving. When it is moving, either at a constant velocity or accelerating, then it is Fk. Kinetic means movement. Movement. Okay, then we highlight our forces. I have my horizontal forces, and then I have my vertical forces. Okay, so we have our vertical and our horizontal forces. Now, Jabu, in the vertical, is the object moving or accelerating up or down? Okay, think about what's going on here. Can you see someone is applying a force to the right? So someone is pushing it to the right, and thus it accelerates to the right. Now I'm asking the up and the down. Is it moving up or down? No. So for the up and the down, we're going to look at Newton's first law, F net is equal to 0. Because it's not moving up or down. In the vertical, it's not moving up or down. Let's say we choose up to be positive. Then we have Fn minus Fg is equal to 0. So you get Fn is equal to Fg. And how do we calculate that? M times 9.8. Liako, will Fn always be equal to Fg? No, it will not always be equal to Fg. Just want to zoom out again. So here Fn was equal to Fg. Here Fn was equal to Fg. Here it is again. But when it's on an inclined plane, Fn was equal to Fg perpendicular. Then I can make it even more difficult and add more forces, but we'll get to that. So they are not always equal to each other. It depends on the circumstance, the scenario that we have. Okay, then if we look at the yellow forces, the horizontal, which law are we going to look at, Princess? Why? Because it's accelerating. F net is equal to m times a, the mass times acceleration. Now, because it's accelerating to the right, it's being pushed to the right, we're going to choose to the right to be positive. So you have Fa minus Fk equals to m times a. Okay, and I'm going to skip a bit now. We can obviously take Fk and say Uk times Fn. Okay, but we've practiced that a million times. So I'm just going to leave it there for now. The next one there on the right hand side. If we draw the free body diagram there, we see we have gravitational force towards the center of the earth. Okay, I'm glad I see some rulers being taken out. You don't have to draw in the inclined plane. It's just when you struggle with your directions, you have to put it in. Okay, but when you put it in as a dotted line. Then you have normal force. Tawana, what is the direction of normal force? Yes, perpendicular to the surface. Then we see we have an applied force up the incline. And we have frictional force. What is the direction of frictional force, Boitsepo? There's one of two things that you can mention. Clue. Something with the surface. There's FK, there's the surface. Parallel to the surface. And in the opposite direction of motion. So if we can see it's being pushed up, then it's in the opposite direction of motion. Right, are you going to leave it there, Tippy Saw? Or what are you going to do? Which one? You're going to split FG into its perpendicular components. So I said you put your ruler on your inclined plane and you're going to make dotted lines there. And then you put your ruler so that you put your ruler so that it's perpendicular to the surface, and you go down, 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 down. You make sure that they are perpendicular to each other, because they are perpendicular components. That is very important. You put in your arrows, you give them labels. You do not make them solid lines. They must be dotted lines. Pocky, what are we going to do after that? No, before that. What is my favorite thing in the whole wide world? Good guess, but no. What? Good guess, but also no. No? No? Highlight! Come on, guys. Huh? Actually not, but some learners do think I like to highlight a lot because I always ask for it. Alright, so you highlight. Highlight the forces that are in the same plane, meaning you are allowed to add and subtract them from one another. My favorite thing in the whole wide world is to eat ice cream. To be in the mountains. In the mountains. What did you say?
I'm just scared.
No, I'm not scared. In the mountains is where I experience God. That is where He is. Yes? I grew up near a mountain. Like if I walked 500 meters, I was in the mountain. And when I lived in Hermanus, I lived on top of a mountain. And in Parijs, where do you see a mountain? I live in Parijs. I live in First Avenue. I have dogs. Huh? Because I married someone. For love. For love.
Can I ask First Avenue is the state?
Yeah, the street. Okay. Come visit. Alright, I'll have ice cream. Alright, the blue forces. Declan, we're with you. In the blue direction. Is the object moving up or down?
It's moving up.
No, in the blue direction. The object is being pushed to the right there. In the up and down, is it moving? No. So in the perpendicular, it's not moving. So we're looking at which law, Declan? First law. Alright. Then we have to choose a direction to be positive. Let's say we choose up to be positive. you guys giggling? Yes, they seem like grade 9 learners. That the hormones just kicked in. Alright. Then we're looking at the yellow forces. We can see it's being pushed up the incline or to the right. So we expect it to be accelerating up the incline, going faster, faster up the incline. If it's accelerating, then it's Newton's second law. F net is equal to m times a. Bongani, which direction will we choose to be positive? Say again? Yeah, we're looking at the yellow forces. My question is, will we choose to the right or to the left to be positive? Why do you say to the left? Okay. Good thought, but if it's being pushed to the right and they say it's accelerating, then we're going to assume it's accelerating to the right. And you choose to the right to be positive. You always choose it in the direction in which it's moving. It's moving to the right, so we choose to the right to be positive. Okay, so we have FA minus FK minus FG parallel is equal to M times A. Okay, then before we go on, I just want to check. Bueno, yes, let's quickly just look here, and then I want to go to your past paper. We're done with that. Then you can put in FK and UK, but we've done that a million times. Okay, so you turn around. We're going to do, or turn your page. Alright, says there, a 2 kilogram object slides to the right on a table until it stops. No, it's your next page, then your past paper. Okay, until it stops. The coefficient of friction is 0.38. You can see no unit. Indicate all the forces acting on the object and calculate its acceleration. Okay, so you hear acceleration, Antoinette. Bing, 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 bing. What goes on in your head? Do you know what's waiting for you? Go. When a. Hey. Now, acts on an object.
Acceleration is proportional to the
And to the of the object is directly proportional to the force. Underneath here, directly proportional to the force. Alright, so they'll ask you to indicate all the forces acting on the object. Now this will count 3 marks. 3 marks means 3 forces. Okay, so I just want to show you here that the object is like you have this object here, and it says it slides to the right. If something slides, does it mean someone is pushing it the whole time? No. If it slides, it means someone did push it, but then it's on its own, and then it comes to a stop. Okay, so someone did push it, but we're not considering when someone was applying the force. It is now when someone is not applying the force anymore. It comes to a stop. Alright, so all the forces acting on the object at Tiamo. Which force do you know is always present? And the direction? Yes. What other force, Mama? The direction? Alright. Morsi, it says it is moving there to the right. But no one is pushing it. There's not an applied force. It's just sliding. Yes, in which direction is friction? In which direction is it moving? Potsepu, please give us the direction of frictional force again.
Parallel to the direction.
Yes. Now don't say left. What did I explain?
The
Parallel to the surface and opposite direction of motion, meaning it's moving to the right, so friction is to the left.
Then you should have given me a switch.
Okay, next one. Right, then we are going to highlight. You highlight the forces that are on the same plane that you're allowed to add and subtract from one another. Is there? Yeah, I actually want you to write an X. X is the not the motion, the displacement. So it's moving to the right, it's being displaced to the right. Alright, now Kumo. Yes. Kumo, they ask for acceleration. In which direction will it accelerate? In the blue or in the yellow? In the yellow. So it means we are going to look at the yellow forces. Okay, so it will accelerate in the yellow direction. Now, Botsepu, your common sense is kicking in, right? I pushed that trolley and it went slower and slower and slower until it stops. What type of acceleration will we have? We will have deceleration. Because it comes to a stop, it is slowing down. So it tells me I will have down deceleration, which means it is negative acceleration. Slowing, I'm writing really poorly now. Slowing down, deceleration. So in my head, I'm saying, okay, they asked for the acceleration, but I think I want a negative acceleration because it's slowing down. Okay, but they did speak about acceleration, meaning Newton's second law. Tawana, in which direction is it moving? To the right or to the left? Which direction is it moving?
moving to the right.
To the right. So we choose to the right to be positive. Okay, if I look at all my yellow forces, I only have one yellow force, and that is to the left. Okay, so I only have a minus Fk is equal to m times A. Let me finish, I don't know. Alright, now they ask us to calculate the acceleration. Do I have the mass? Yes, they said 2 kilograms. Do I have Fk? No, I have Uk. So I must first go calculate Fk and then I can substitute it in there. Okay? So I'm going to do that in my info table here on the right hand side. What's wrong? Go to your first page. Can you see it's two different things? The one is just a coefficient, and the other one is the frictional force. Okay. Right, so we want to calculate the frictional force using the UK. The UK is 0.38. Oh, and now I need the normal force. They didn't give me the normal force. But I did draw it in my diagram. The normal force was blue. Is there another blue force that can help me determine Fn? Yes. So, inside my info table, I have another info table. I'm going to look at my blue forces. My blue forces, it's an object moving up or down? The object is sliding to the right. It's not going up or down at all. So it's the first law, Fn is equal to 0. F net is equal to 0. You can choose up or down to be positive. It doesn't matter. Okay, I'm just going to do this quickly. You'll see that Fn is equal to Fg. You'll first say Fn minus Fg is equal to 0, blah, 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 blah. I'm just going to zoom in here a bit. So what was the mass? Was 2 kilograms at the top times 9.8, because that is how you calculate Fg. You must times 9.8, and then you get 19.6 newtons. Yes? Then you're going to take that 19.6 is equal to Fn, and you're going to substitute it in there. So I'm just going to take a different highlighter, that I'm going to substitute in there. So times 19.6. And that gives you 7.448. Yes? Alright. And then I'm going to take that 7.448 and I'm going to substitute it in there. Must be negative 7.448. Why do I not round off? It's not my final answer. You round off your final answer. The mass of the object was 2. Must I multiply that 2 with 9.8? No. And I want the acceleration. Where are we with our questions? Tawana, your turn. Your eyes was closed. It showed me that it's your turn. Tawana, what are we going to do? How are we going to calculate A? Yes, you're going to divide by 2. It's not a difficult question. And you get negative 3.72 meters per second squared. There's not 3 marks. I said the forces here is 3 marks. I'll show you now. Are you allowed to leave your answer in the negative? No. You're going to write, this means 3.72 meters per second squared deceleration or negative acceleration or in the negative direction. Okay, this one can count up to 5 marks. I think by the end of this chapter we'll only count 4 marks because this will be easy by the end of this chapter. But it will be formula, doing that calculation, showing that, 1, 2, 3, substituting that, and your answer, 5. Okay, next one. Yes, unfortunately. We should actually do one more chapter, but I don't think we'll get to it. Maybe we get to it, but in my books, you're only going to write on chapter 1 and chapter 2. 75 marks, 1.5 hours.
And if you do the other chapter, how much?
then it will be 100 marks. But I'm going to stick to 75. I'm going to stick to those two. Alright, next one. It says there, a 20 kilogram crate is accelerated up a 15-degree incline at 0.1 meter per second squared by 110 Newton force. Calculate the coefficient of friction between the crate and the surface. Okay, so a lot of information there. You are first going to tell yourself, alright, they speak about acceleration. In my head, I think. You're all too scared to say it because you... Newton's second law. Then they speak about you must calculate the coefficient of friction. In my head, I think, okay, where do I find the coefficient of friction? There's only one formula. So Fk is Uk times Fn. So if I must calculate the coefficient of friction, I must find Fk and I must find Fn. Can you see my planning? Alright, I'm not done with my planning. What else must I do to help me plan? Draw a free body diagram. Okay, you're going to write very small. This free body diagram will count 4 marks. 4 marks tells you 4 forces. Okay, your forces are, princess. Gravitational force. Direction. Yes. If you guys don't hear my voice in the exam, I'm not doing a good job. You must hear my voice. That's what you should hear. Yes. Then the next one, Liakwe. Yes. Yes. Another one, Jabu. In which direction? In which direction is it moving? So in which direction is friction? To the left. But you're also going to say it is and in the opposite direction of motion. And your last force is your applied force. Someone is pushing it up. Bokyo, are you going to leave it there? No. What are you going to do? Say again? Which one in its rectangular components? Say again? Gravitational force. You're going to split up into your rectangular components. You're going to make sure, or perpendicular components. Yeah? Ah, man, potato. No. Perpendicular components. And remember that is theta there. What's your next thing, Tipiso? Highlight. You must know why you highlight which color. Which force, which color. Don't just copy me. You must know why you're doing it. If you don't know, you must ask. Otherwise, it's irrelevant whether you highlight or not. Alright. Now, when I go... Okay, you tell me why did we highlight these 3 forces the same color? You tell me. Think. But what do you see? What do they have in common? same plane, same direction. So everything, if there's another force to the right and another force to the left, you highlight all of them yellow.
Didn't you say we must not have it? We've been highlighting everything.
I said we're not going to highlight this one, ne? Because it's not in one of the planes. Are you with me, princess? Ciao. All right. So I'm going to go back to my planning here. FK, I highlighted yellow. So for FK, I'm going to look at the yellow forces. FN, FN, I highlighted blue. So for FN, I'm going to look at all the blue forces. So this one will count a lot of marks. This one can be up to 6, 7 marks. Okay? Because why? We want to get UK. But to get UK, you must get FK and you must get FN. So you're going to do 3 calculations. 3 separate calculations. Right. Declan, which one do you want to start with? Calculate FK or calculate FN? FK. Sorry, so for FK, we're going to look at the yellow forces because it is yellow. Bongani, the yellow forces.
Yeah.
Which law are we going to look at? 1, 2, 3, 4?
1.
Why do you say 1? Look at the yellow forces.
You. So I should say everything, ma'am.
Now, I'm just asking which law. The first one, the second one, third one, fourth one, and why?
First one, ma'am, but I don't know how to explain it.
The first one you use when what happens? It's at rest or at constant velocity. The yellow force is here. Is it at rest? Is it at constant velocity? It says the 20 kilometers accelerated up the incline. You must know why we choose which law. Because in the exam, I'm not going to be there.
So is it that you're going to ask us in the exam for why we choose them?
No, you must just know. You must choose and choose the correct one. So it's the Newton's second law because it's accelerating up the incline. So F net is equal to M times A. Antoinette, in which direction is it accelerating? To the right, so we choose to the right to be positive. Okay, so we have FA minus FK minus FG parallel is equal to M times A. Why minus? Which direction did we choose to be positive? To the right. So to the right, FA minus minus. Okay. What are we busy calculating? We're calculating FK. So I'm not going to fill in FK. Okay, I'm going to leave it as it is. Can I elaborate, go on with FG parallel? Yes, it's FG sin theta. So I'm going to write in FA minus FK minus FG sin theta is equal to M times A. I think you're going to need okay, now I'm going to substitute, put in values. FA that gave me is 110. FK is what I want to calculate, determine. FG is the mass times 9.8. So the mass was 20 times 9.8. Is 20 times 9.8, and then the sin of theta was 15. Equal to the mass is 20 and the acceleration is okay. So I substituted everything. Up until there you can already get 4 marks. Okay, so we want to get FK. Whose turn is it? Siamo. You guys check her. You don't trust her. You check. Antoinette did answer something. I asked which direction do we choose to be positive, I think. No, guys. Sometimes you get an easy one. Sometimes you get a difficult one. That's life. Life's not fair. Hello. You all should have your calculator out. I can ask anyone. If she gets it wrong, I'm going to ask the next and then the next and then the next. Yes. My rules, my choice. My class, my choice. First pass, then you can set your class.
That's how we.
Yes. Almost. Did you say that minus that? But what about this? Not divide, minus.
What's wrong with you?
No, not divide. Don't listen to mama.
What's wrong with you?
Nee man, bongoni. Yes? But I'm assuming I take FK to the other side and then I swap them around again. Ooh, you guys, your mathematics. Say again? Yes. But remember, it's not your final answer. 27-1, eh? You know, I will go crazy. Hi, sis. This is for the other teacher that's doing her best.
She's doing her best.
Yeah, she's trying. Remember, in maths class is more than you guys, ne? And already you guys are very talkative and commenty and whatever. Yeah. Okay. Are you focusing here? All right. So, are you done, Bookie? All right. So, we got FK now. Shh, I'm checking. I got FK. Now I must calculate Fn. Okay. What's my plan? I must get UK at the end. I first calculated FK. Now I'm going to calculate Fn. Fn is the blue forces. So, I'm going to look at the blue. Okay. The blue forces are there. Mama, is the object moving up or down? No. So which law? Newton's first law. Alright. And you can choose if you want to take up or down to be positive. It doesn't matter. I'm going to choose up to be positive. Then I have Fn minus Fg perpendicular is equal to 0. Alright, so Fn is equal to Fg perpendicular. How do I calculate Fg perpendicular? Fg cos theta. Just to save space, I'm writing next to each other. Then I'm going to substitute in values. Fg is 20. Can I leave it at 20? 20 times 9.8, ne? Because it's Fg. It's being pulled down the force. Times the cos of 15. Remember, everything you say is recorded here today, ne? It goes on YouTube. What you say about other teachers? I didn't say anything.
You didn't say
If you're guilty mostly. Did you calculate? It is. She just said first law. No. One hundred and? All right. So now we have Fn, we have Fk. Now I can calculate UK. Okay, so I just took the the formula and I put in my values. And now what must you do, Kumo? To calculate it, are you gonna subtract, divide, multiply? Divide. Yes? Say it with confidence. What do you want to say? 0,3? Zero. Yes. No unit. Okay, now. How would you know you're on the correct path here? If the answer must be smaller than 1. So if you get a 0 comma, you know you're on the right track. If it's bigger than 1, you know somewhere you did something wrong. So it cannot be bigger than 1. Alright, this is a long one, I know, but this is the type of question you can expect in a test or exam. We can also make it more complicated. Yes.
They're also human beings.
Pongani, does it look like I'm in control of what you should know? I wish I was paid so much that I was in control, but I'm not. Okay, right. So, what I want you to do for homework is in your past paper, if you go to question 4. Past paper, question 4. The past paper, November 2021. No, I handed out 2021. Question 4 on page 7. Okay, if you go to question 4 on page 7, there you see a box that is pushed over a horizontal surface from A to B. Okay, so in your writing book, I'm going to start with helping you. Okay, so we're at November 2021. We're looking at question 4. And you're going to do question 5 as well. It's a pleasure. All right. All right, so question 4. They say there the box weighs 60 kilograms. I just want to say something. Can you see the force is applied down like that? Yes. Okay. So if you were to draw a free body diagram, this is important. You have gravitational force, you have normal force, Then you have friction. They say it's a rough surface, so you have frictional force. And then you have a force going down there, the applied force. Can you see the applied forces at an angle? What are you going to do with it?
We're gonna cut it.
Yes, you're going to split it into its perpendicular components. Careful, highlight and carefully highlight before you start. Perpendicular.